Swayam Prabha. Digital India. Educated India.
Hello, good morning. Welcome to the course on comprehensive view of speech processing. So today lecture is 10 in the series. Today we are going to discuss about the knowledge sources in speech, and then we are also just start the topic of processing of speech. So yesterday we are discussing about the various knowledge sources present in speech. So if you look at this slide, so as we have observed that the speech contains various types of information, and as a human we can able to make use of all that information, or from a speech signal we infer various components, or you can say that various types of information that is embedded in a speech, we can able to experience that, and we are using that as a production or a perception mechanism. So if you look at here, I just mentioned some of the some types of information that is embedded in speech. Like the first and a very important one is the message. It's like the message to be conveyed or a thought to be conveyed, that is from the talker point of view, and whereas the intended person has to receive that message. So like in the context of the speech transmission or a speech, where a talker used to want to convey some message to a listener, and a listener want to receive a message from the talker. So from both the perspectives, from both the talker and the listener perspective, the message is very important. So from a speech signal, so the message, the intended message that to be conveyed from a talker perspective, he will generate the speech where the message is embedded in that, and then he will generate the speech, and it will be propagated in the form of acoustic pressure variations. And from listener perspective, and this acoustic signal will be received by the hearing mechanism, and then it will be reached to the higher centers of a brain, and then the message will be interpreted. So that way the message is a very fundamental or very important information that is present in speech, and along with the message from a speech, after perceiving the speech, so one can able to, or we can able to infer that this speech utterance is spoken by a particular speaker and all, right. And we also know that actually this speech is spoken in a particular language. So that is also will be observed by the listener and all, and we can able to easily discriminate that whether this speech is produced by human or it's like a non-human, like a robot or by a machine. So that can be easily discriminable by a human. And there are other patterns that are other very important information that is present in a speech, known to be like intonation, duration, and the emphasis. So these things we discussed. As intonation pattern means it's nothing but a pattern of pitch or pattern of rate of vocal folds vibration, and this depends on the type of sentence, or like the kind of the message that need to be conveyed. So accordingly the intonation patterns will be present in the speech, and similarly the duration patterns also. So the duration patterns also, that depends on the type of speech, or what kind of a message need to be transmitted, and so that way the duration patterns also are embedded in a speech. So that gives you a proper naturalness to the speech. And stress, as I mentioned, that depending on the message, will try to emphasize certain words and certain phrases. So with that the intended person can able to understand the message content or the intention of the message also. He can understand, and he can able to respond back. And we also, by listening to the speech, we can also discriminate the accent of the speaker, whether this person is a native speaker or whether the person is like his mother tongue is different from the language where he is speaking right now. So, and also can also identify that the dialectal region of the person also based on his speech, right. And then as I mentioned, like the emotions also a very important part of the speech. So by embedding by blending appropriate emotions, then the proper semantics of the message will be conveyed to the desired target people. So that way by listening to the speech we can also perceive the what is the underlying emotions that are present in speech, that can be understood. And similarly the health of the speaker. So a speech from this given speech you can able to understand whether the speech is produced by a normal person or a person having certain vocal disorders, maybe like a paralysis of certain vocal folds, or a cancer in the mouth, or like nodules in the vocal tract. So all these disorders can able to identify from the speech by perceiving the speech. Like at least you can able to discriminate that whether the speech is produced by a normal human or a person having various different disorders other than a normal. Like and similarly if you listen to a speech you can able to perceive the background information also. The background information that is present in a speech is also can be inferred. So all these various types of information we can able to easily, as a human one can able to easily infer, and that can be effectively utilized for various aspects, right. And our objective is that all this information is present in a speech. So the way the humans are utilizing this information in effective purpose of the speech, the intention of the speech or the language of the speech, identifying all of them, the same way we expect the machine also by making use of all this information in performing various speech tasks, like such as inferring the message, or like identifying the speaker, identifying the language, or like identifying a background. So with that the speech can be enhanced, right. So all these for various tasks the machine can able to effectively utilize the different types of information that is present in a speech, so that we can able to perform the speech task more efficiently. And here as I mentioned that for a machine the speech signal is available in the form of digital form, and that you can able to see if you analyze the speech in a time domain, then this is the time domain representation of a speech, and this corresponds to a sentence. A speech utterance corresponds to mata or pita ka aadar karna chahiye. And from this time domain representation you can see that here in this the speech for producing this particular speech utterance, it requires about 3 seconds closely, right. And here the scale is given in terms of number of samples, and suppose if you consider that the sampling rate is 8 kilohertz or 8000 samples per second, and here there are 25,000 samples. So therefore this total speech signal is occupied around 3 seconds duration, and in this 3 seconds duration you can able to see that the speech signal amplitude is varying, varying. At sometimes we have very small amplitude, at sometimes we have like a higher amplitudes, and this amplitude is also varying, and that depends upon the speech utterance. And here the speech utterance is nothing but a sequence of sound units followed by sequence of words and so on. So as per the sound unit it has a different amplitudes, right. If the sound unit is a consonant, it may have a lower amplitude. If the sound unit is vowel, then it has a higher amplitude. So likewise depending upon the sound units you can able to see that there is a variation in the amplitude across the like as you progress the time. And you can also see that at certain portions the signal is periodic, that you may not observe over here, right. Whereas if you can able to stretch the signal in a horizontal direction, you can able to see the periodic patterns over here. And here the speech is uttered in a continuum, like we uttered a complete sentence. So here if you look at here, this sentence contains there are about 6 words, right, 7 words, and it may have some 15 to 20 sound units and all, and you utter this sentence in a continuum. So therefore the speech signal looks like this. And whereas, for example, we know that there are 15 sound units, and if you utter each of the sound units in isolated manner, and then if you try to concatenate that, it will not appears like a natural speech. You can able to clearly discriminate the speech which is uttered in a continuum versus the speech that is concatenated the sound units in series or in sequence. So, you can able to clearly make out the difference and all, because the difference is that when you produce a speech in a continuum, the characteristics of a sound unit that depends upon its context. That means what is the preceding unit to this and what is the following unit to that. So, because when you are speaking continuously, our vocal tract are the articulators that are present in a oral cavity. So, the movement of these articulators are the movement of or the shape of the vocal tract. So, that changes according to the sequence of sound units. If you utter a single sound unit, the shape of the vocal tract or the movement of the articulators are very different from the same sound unit if you uttered in a context, or if you uttered in between the different sound units, then that shape or the movements of articulators are very different. And this phenomena is known to be a co-articulation, and that is very important in when you are processing the speech, because we are processing because to identify or to, in case of speech recognition task, the goal is that from the given speech signal we need to identify what are the sound units that are present in a speech, right. That is the objective of a speech recognition system. So, in that case, so here we need to be realize that the characteristics of sound units, they differ from based on its context, based on the context that is present around that particular sound unit and all, right. So, even though there are few sound units, there are about 40 to 50 sound units, but its characteristics will vary, that depending upon where they are present, whether they are present at the beginning of a word or at the end of the word or middle of the word, and what is the context, which sound unit is prior to that uttered and which sound unit is going to be uttered after this. So, all these matters. So, therefore, when you are processing the speech or when you are performing a speech recognition, so you need to be conscious about the co-articulation effect. So, with that, the characteristics of a sound unit will vary based on its context, based on its positional information and so on. And here we just, as I mentioned that in the previous slide, so there are various knowledge sources or various types of information that is embedded in speech, where the humans can able to infer that, and they can able to make use of that, exploit that very effectively for performing the speech activity, like as a talker or as a listener perspective. So, if you want to perform, or if you want to perform the machines to a similar activity like humans, like the machines also should infer that information, the different types of information that is present in a speech, and it can be effectively used for carrying out various speech tasks, right. And towards that, here we just derived different types of information from the speech signal using appropriate tools and signal processing methods, and from this we can able to derive some conclusions, or we can able to derive certain discrimination aspects in carrying out the various speech tasks. So, here in this figure we have 5 subplots. The subplot in the top, here this is a speech signal in time domain, the same signal whatever we have seen in the previous slide. And the second subplot here from top, so this is known to be energy contour, and here, as I mentioned, that you can able to compute energy for the whole speech signal, right. So, in that case you will get the single number, or you can say that this is the total energy present in a signal, and that is not making sense, that's not making sense, right. So, but here we want that, because here the speech signal contains a sequence of sound units, and we want to observe that how the energy contour or how the energy is distributed in this particular speech utterance with respect to time, right. And so, therefore, here the energy contour is computed with respect to frames. That means for every frame we will compute the energy, right, and then likewise we will compute the energy for every frame, and then we will plot those energy values in sequence with respect to time, with respect to its frame instance, right, and then you can get the energy contour. So how do you get energy? We know that sum of the sample amplitudes, squares of this amplitudes provide you the energy, right? So that way, if you compute the energy of a frame and energy of all the frames that are present in a speech signal, and then if you plot all those energies, then you can able to see the plot something like this. So this is the energy contour. So from this energy contour, we can come to know that there are places where if there is no speech signal, the energy is very minimum or very insignificant, and the presence of a speech signal where we have a variable amplitudes are observed, right, that depending upon, as I mentioned, the prominence and so on, if there is a stressed word, then the energy will be more during the utterance of that particular word, and if the word is at the very beginning, the energy may be lower, and again if the words are at the ending, the energy may be lower. So that way, different types of information that can be observed by analyzing the energy contour, right. So simply by looking at energy contour, then we can come to know that where the speech is present and where the speech is not present. That means speech and non-speech regions can be identified using the energy contour, right. And also the peaks in the energy contour, they also reflects the prominent regions in the speech signal and all. And the next contour or the next plot is here is the pitch period contour, and so if you take the reciprocal of this, gives you the pitch contour. As we had discussed, the rate of vocal folds vibration gives you the pitch, and in the time domain, it's known to be the time duration for every pitch, for every period of a signal is known to be pitch period and all. And here the pitch period was plotted here, and so as I mentioned in the last class, so the pattern of this pitch period, if you analyze globally, that means with respect to sentence or with respect to the phrase, it provides you certain information, like if it is a declarative sentence where the pitch contour is observed to be at the beginning it will be higher, and then as you move on towards end of the sentence, the pitch contour or the pitch will be lowered, right. Whereas in case of interrogative sentence, it is other way, where at the beginning the pitch will be slightly lower, and as you move on to the end of the sentence, since it is an interrogative sentence, the pitch will be increased, a pitch rise in the pitch can be observed. Likewise, we have some other cases where in a sentence itself, in a phrase 1 the pitch will be lowered, and in the phrase 2 the pitch will be increased. So likewise, we have, by observing a pitch contour at a global level or at a sentence level, it means at a level of 3 seconds, 5 seconds, or at a sentence level, where you can able to observe certain information, you can able to find the discrimination between the sentences based on their semantics, right. If it is a declarative or if it is interrogative, and if it is emotional content is present. So all that information can be observed by analyzing the pitch contour or by analyzing the dynamics of a pitch contour at a global level, right. And similarly, if you can able to observe at a world level also, there are variations in the pitch contour, right, and these variations indicating that actually, so whether the word is a prominent or not, right. And we also know that at the beginning, the words at the beginning of a sentence, they have certain shape of the pitch contour, and the words at the end of a pitch contour, they have certain shape, right. And the words having longer words having more sound units, they may have pitch patterns are different, right. So all that information that can be analyzed, if you analyze a pitch contour at a local level, that is at within the world level, if you analyze, you can come to know about some information about the nature of the words with respect to the pitch contours. And similarly, again, if you go still further, again even within the word also the pitch contour varies, right, and even within the sound unit, like within the syllable also, you can able to see the variation in the pitch contour. So that provides you some more detailed information or more finer level information with respect to the syllables or sound units or words and so on. So then the next subplot is like as I mentioned, it's known to be glottal closure instance, right. So when you are uttering a speech signal, when you are uttering a speech, like majority of the speech is produced due to the voiced excitation, that is due to the vowels, and we know that voiced excitation is nothing but vocal folds vibration. The vocal folds will close and open. So in this, the closing phase is very important, where you can able to see high burst of the pulse or the breathing, or you can say exhalation of air will be released. And so the since and wherever these glottal closure instants are there, so that will be reflected in the speech signal as the higher amplitude regions. And since it bearing the higher amplitude regions or higher amplitudes at the glottal closure instants corresponds to glottal closure instants, and where the signal strength is very high and the impact of noise will be less. That means the signal to noise ratio at a glottal closure regions are very high. So therefore, usually for processing the speech by machine at a glottal closure regions gives you the genuine information or give you the robust characteristics of a speech. So therefore, they are the important regions for processing of speech by machines. And these are the glottal closure instants, sequence of glottal closure instants, or they are also known to be the instants of significant excitation, because at a glottal closure the excitation strength is very high. So you can able to see a dominance, or you can see the highest signal or the peak signal is present during the glottal closure, right. And the last plot is all of us are familiar with this we have discussed when we are discussing the acoustic phonetics, and this is the spectrogram plot for the given speech utterance and all. And you can able to see in the spectrogram, we have seen that the spectrogram is plotted at a frame level, and for every frame we will compute a spectrum. Here the spectrum is nothing but that particular frame is constituted by what are the frequency components that are constituted by that particular frame, and then how the energy is distributed, right. So this entire information, like the spectral information, that is nothing but what are the frequency components present, and in that frequency components how the energy is distributed. That it means that which of the frequencies are dominant and which are insignificant. So all that information can be observed from the spectrogram. And here the black patches or the black regions, they corresponds to the frequency regions where the energy, the most of the energy or significant energy will be concentrated over here, right. And here the spectrogram is plotted between 0 to 4 kilohertz. So you can able to see in this range there are black patches around, there are close to about 3 to 4 black patches at every sound unit or in every region, right. And so these black patches, sometimes you can see that there is a rise of certain patches and fall of certain patches and all. So these things are indicating that because there is there is a higher dynamics in these black patches, they indicates that these are the sound units corresponds to the diphthongs and all. And here this is chahiye, where the diphthong like E and A, combination of E and A will be there. And likewise here also mata aur, here this is corresponds to aur, where you can see a change in the formats. It is clearly indicating that there is a presence of diphthong, and there is no energy in the spectrogram indicating that there are the pauses or the silence regions. So all that information is present from the spectrogram. So here we extracted this information using appropriate tools or signal processing methods, and this information can be effectively used in various speech tasks for efficiently performing the desired speech tasks and all. And this is the plot, this particular figure indicating the same subplots as we have mentioned in the previous slide. But here for the sake of more clarity, we have taken only a 0.5 second segment of a speech, 1 to 1.5 segment of a speech has been taken, and the corresponding the informations whatever is extracted in the previous slide, the same were plotted here. And from here you can clearly notice that in the time domain signal also you can able to see a periodic pattern, and again this periodicity also varying with respect to time, that also can be observed. So the same thing here you noticed over here, right. And whereas here almost like periodicity is constant, whereas here the periodicity is slightly increased over here during this region. So all these observations can be noted from these individual plots. And similarly this is the energy plot, right, and you can see that energy is very low, corresponds to like silence regions or a pause region, right. and similarly this is the spectrogram corresponds to this particular 0.5 segment of speech, right. And you can see clearly there are 4 formats or 4 significant frequency regions where the energy is mainly focused. And so that way from the previous slides what can be inferred is that, so from a speech signal, by using appropriate tools and signal processing methods, we can able to derive certain information, and then this information can be properly captured or properly represented in the form of appropriate features, so that these features can be used for example discriminating the sound units, or these features can be used for discriminating the speakers or discriminating the languages and so on. And now here we will see that for extracting the previous information, like the various types of information that was mentioned in the previous slides, so we need to process the speech at different levels. So for example here at a segmental level means, suppose if you process the speech at a duration of around 10 to 30 milliseconds, or like it is not very crucial, like even the 40 milliseconds or 20 milliseconds, all of them, like. So if you try to analyze the speech around 30 milliseconds or 40 milliseconds, right, and that analysis is known to be segmental level analysis, and from this analysis or from this characterization we can able to observe the positioning and movement of articulators, right, and the shapes of the oral cavity, right, nasal cavity, and voiced and unvoiced excitations, and the periodicity of the signal, and form and structure. So all these informations you can able to infer or you can able to capture if you analyze the speech at this level. That means if you analyze the speech at a segments of or at the durations of 20 milliseconds or 30 milliseconds, we can able to infer all these things, right. Otherwise, suppose for example, if you try to analyze the speech at a longer segments, suppose if you try to analyze the speech at a second and 1 second duration or half a second duration, so in that case we can able to see certain other information, but here if you want to perceive exactly the shape of the vocal tract, means here during the 1 second the shape of the vocal tract it changes, because in 1 second we may utter, there are 3 or 4 different sound units. So for each sound unit the shape of the vocal tract or the movement of articulators, they are different. So therefore if you try to analyze in 1 second, you do not perceive the shape of the vocal tract, because in that 1 second the shape of the vocal tract changes continuously, right. So if you want to analyze the shape of the vocal tract, right, so in that case we need to analyze the speech signal at a range of 20 to 30 milliseconds. So in that 20 to 30 milliseconds the vocal organs will not move. That means we can assume that the vocal organs or these articulators, the movement is almost like a steady or like they are not move within the 20 milliseconds or within 10 milliseconds. So therefore if we take a segment of 30 milliseconds, we can assume that in that region the vocal tract shape is almost like a steady, or the position of the articulator or the movement of articulator or the shape of the articulator, that is almost like is steady or is a constant. So that way all that information you can able to infer if you analyze the speech at a segmental level, right. And suppose for example at a suprasegmental level, it means that here from the nomenclature or from the terminology itself, it is clear that we are analyzing the speech at different durations, duration intervals. So at the segmental level we are analyzing the speech at a duration intervals of 20 to 30 milliseconds, whereas suprasegmental means we are analyzing the speech beyond 100 milliseconds, So it means that for example we have seen in the previous slide a pitch contour, if you analyze at a global level, it means that at a sentence level or at a phrase level, where the duration of the phrase will be like a more than a second, right, or duration of a word means it's like more than 100 milliseconds, it will be around 300 milliseconds or 400 milliseconds and so on. So in that region, suppose for example if you want to analyze the pitch contour at a global level, the segmental analysis will not help you out. Segmental analysis will give you that in that segment what is the pitch, it's like instant pitch, in that segment what is the pitch, right, what is the pitch period, that information will be provided. But here we want the trend. In the sentence level, how the pitch is varying. If the pitch is rising, or pitch is gradually rising, or pitch is monotonically decreasing. So that is the trend that we want to infer at a global level. If we want to infer such information, that means we want to infer the dynamics of a pitch at a global level. So at that time, in that case, if we want to analyze the speech at a segmental level, a supra-segmental level will be appropriate, where you can able to see the global level, the trends of the pitch variation or intonation patterns at a global level can be observed. And similarly, the duration patterns also, how the durations are varying, because the duration of a sound unit like a vowel itself is like 200 milliseconds, 150 millisecond and all. So in that case, if you analyze at a segmental level, we will get only partial information. So therefore, if you want to analyze the duration patterns, how the durations of the sound units are varying, right? So that kind of information, if you want to infer, you need to analyze the speech at a suprasegmental level. Similarly, energy contour also. If you try to analyze the energy contour, for example, if you look at the energy contour, so from that you can able to identify the speech or non-speech. So that information or that kind of information is available only by analyzing the energy contour at a suprasegmental level. And similarly, by analyzing the patterns of a speech signal at a word level, it's nothing but beyond 100 milliseconds, we can able to perceive that whether the word is stressed or not, whether the phrase is prominent or not. So all that information can be observed only if we analyze the speech signal at a suprasegmental level. Similarly, the melody, right? The melody means here this is in the context of music. Suppose if you try to analyze the like our Hindustani music or a Carnatic music or any Western music, if you analyze at very smaller segments like 30 milliseconds or 40 milliseconds at segmental level, we don't make out anything from that from that 40 milliseconds segment. If you analyze the melody or if you analyze the pitch, we don't get anything, right? If you analyze the melody at a longer segments, quite longer segments, then we can make out, then from that by analysis we can able to make out that, so what is the particular raga of this of this music, or what is the scale of that music. So all this information you can able to make out by analyzing the melody at a suprasegmental level. Here melody is nothing but like you can say that because in the context of music, the melody is attributed to both the vocal music and as well as the non-vocal also. Non-vocal means we have different instruments that will be accompanied the vocal music. So even for that instruments also the melody will be attributed. So if you want to analyze the melody, we need to analyze at a suprasegmental level. Similarly, the syntax, semantics of a message is also conveyed, is also inferred only if we analyze at a suprasegmental level, because we have syntax means based on the the sentence nature, actually whether the sentence contains any interrogative phase or like a declarative phase or like any other thing. So that can be observed only by analyzing at a suprasegmental level. That means if you analyze the pitch contour at a suprasegmental level, then one can able to comment on the sentence, whether the sentence is a declarative sentence or interrogative sentence and so on. And similarly, the semantics based on the meaning, like the appropriate emotions will be embedded in a speech. So therefore, if you want to analyze the semantics of a sentence or semantics of the speech, then it's better to analyze the speech at a suprasegmental level. For example, you can see that a newsreader speech, if you want to analyze, if you see the newsreader speech versus a speech that is produced by a storyteller, for example, where in case of newsreader speech, it's like just reporting the news, where most of the sentences are declarative sentences. Whereas in case of storyteller, suppose we want, because the storyteller's objective is that we want to give more emphasis, or we want to attract the audience or attract the children are paying attention towards the story. So therefore, he will embed different emotions, and with that whatever the speech uttered by the storyteller is very different from a speech uttered by newsreader and all. So all this information you can able to grab by analyzing the speech at a suprasegmental level, right? And there is another one known to be subsegmental level. So here in this case where the speech is analyzed at below the segments, it means that below the pitch period. If you look at a pitch period where you can able to see the vocal tract is stable, articulators are stable, right? They cannot move below the within 10 milliseconds. You cannot observe any movement of the articulator, right? But there is an articulator here, vocal folds vibration. They vibrate because there is a movement within a pitch period. That means the entire pitch period constitutes one cycle of a vocal folds vibration, right? So the vocal folds opens, then closes, right? It total constitutes of 4 different phases. Suppose I assume that vocal folds are open, right? And then it's known to be open phase. Then when the vocal folds try to close, it's known to be closing phase. And once the vocal folds are closed, it's known to be closed phase. Then afterwards, the vocal folds starts opening. It's known to be opening phase. Then afterwards, there is a steady open phase. So that way, each pitch period, or you can say that each period of a signal, periodic pattern of a signal, can be viewed, can consist of 4 different phases, like closed phase, that means complete closure of vocal folds. Then the opening, that means from a closure to the open phase, that is a dynamic one, right? It's a continuously varying. And afterwards we have open phase, and then afterwards again a closing phase will be there, right? So that there are total 4 different phases. If you want to analyze those phases, right, the duration of the phases, or the rate of closing or rate of opening, that means how fast the vocal folds are closing, how fast the vocal folds are opening. So these kind of things, this kind of information, if you want to analyze, we need to analyze the signal the below the pitch period, that is like within like 3 to 5 milliseconds, and it's not to be subsegmental level of analysis. And so this subsegmental level analysis used to analyze the shape of the glottal pulse, and the different phases in the glottal cycle, right? Different regions in the glottal cycle, like open closure regions of glottal cycle, and the consonant regions also, because the vowels are pretty longer in duration, right? So therefore you need to go for an analysis of the segmental level, whereas the consonants, sometimes the consonants are very small in duration, right? Because you see that consonants are very dynamic, like you have a complete closure or a partial closure, release of the closure happens to be your consonant, right? So in that case, suppose if you analyze at a segmental level, that is 30 milliseconds, 40 milliseconds, then sometimes the entire duration of a consonant itself is less than that, right? So if you take a 40 milliseconds, then you can get a gross characteristics of a consonant, or even some of the vowel portion also includes into that. So therefore, if you want to analyze various regions or the characteristics of a consonant very effectively, then the subsegmental level analysis will be very much useful and all, very much useful. So that way we have a different types of, we need to analyze the speech at different levels to acquire the different types of information, like the segmental level analysis, subsegmental level analysis, and suprasegmental level analysis. And we also know that we already come across this co-articulation level or co-articulation knowledge. It's nothing but, co-articulation level is nothing but constraints due to the linguistic context. It means that the utter, because always the speech is like associated with the language. So whatever the message if you want to convey, and that message has to be conveyed in appropriate language, it's nothing but a sequence of words, and again the words consist of sequence of sound units. And as I mentioned that, and the characteristics of the sound units or the characteristics of these words are depends upon its context, So therefore, if you want to discriminate the sounds, or if you want to, like from a synthesis purpose, if you want to produce the sounds, you need to be very careful about the co-articulation knowledge that need to be embedded, or that need to be discriminated, or that need to be analyzed very carefully, so that you can able to perform the speech recognition task very effectively, or you can able to identify the sound units very effectively. And at the same way, in the case of synthesis point of view also, so from the text you need to generate the speech. So in that case, we need to, first of all, you need to identify the sounds from the text, and afterwards you have to see that what is the context. Suppose a particular sound has to be generated, means you have to see that what is the context of this particular sound unit, so that accordingly you need to produce the characteristics, or you need to generate the sound in view of the co-articulation of the preceding and following sound units and all. So these are the various knowledge sources that are present in a speech, and if you want to exploit these for various speech tasks by machine, so one needs to analyze the speech at different levels, so that he can able to extract the information, and he can make use of that effectively for performing various speech tasks. Yeah, right. Yeah, this is the one what we have discussed. Again, information at different levels. At segmental level, we have seen the periodicity can be observed, voiced, unvoiced decision can be analyzed at a segmental level analysis, form and structure, shape of the vocal tract, and so on. And similarly, at suprasegmental level, this is also known to be prosody level. The suprasegmental level analysis is also known to be the prosody level, or the knowledge that is present at a suprasegmental level is known to be prosodic knowledge, and this is usually more than 100 milliseconds. If you analyze, you can able to see that. And at suprasegmental level, these are the information that can be observed or that can be analyzed here. Duration patterns at a gross level and finer level. Gross level means, suppose if you analyze at a sentence level, we can able to analyze the durations of the words. Suppose the sentence contains 7 words. So in that case, one can able to analyze the duration patterns of the words in a sentence, like with respect to their positions, one can able to analyze that. And within a word, if you want to analyze the durations of various syllables, that is known to be finer level analysis. And even if you can go still lower level also. Suppose we have a syllable, or if you have a syllable, or within the syllable, like what are the different units that are present. We know that syllable is nothing but a vowel is must and a consonant may or may not present, right. So in that case, actually here in a syllable, what are the duration patterns of the consonants and the vowels, constituting vowels and all. And even if you go still further, even the vowel itself, you can able to find the duration, how it is varying and all, like what will be the characteristics of the initial portion of a vowel, steady portion of a vowel, and the final portion of a vowel, right. So all this information can be analyzed if you analyze the duration patterns at a gross level, finer level. Similarly, the intonation patterns also at a gross and finer level, like at a sentence level, if you analyze the intonation patterns, you can get certain information. And if you analyze the pitch patterns at a word levels, you can come to know that if the word, whether the word is stressed or prominent or emphasized or not. So that information will become to known. Similarly, energy contour. By analyzing the intensity contour, we can say that whether the sound units are prominent or emphasized or not. Co-articulation, stress, prominence. So all this type of information can be analyzed if you analyze the speech at a suprasegmental level. Yeah, then the subsegmental level, as I mentioned here. So this is a glottal volume velocity waveform, as we have seen earlier, and here you can see that this is a closed region, right, and afterwards it is a opening, right. So you see the phenomena, because we produce the speech during exhalation of air, and again free exhalation of air cannot produce the speech, as I mentioned. It has to be constrained. One way of constraining the air, one way of restricting the air, one way of like putting a constraint on the air is because due to the vocal folds. The vocal folds vibration means the vocal folds, when it closes, whatever the air that is releasing from the lungs, it will be stopped. It will be stopped. So there is no air coming out of it. So therefore the velocity, there is no air coming out, so the velocity will be 0. And then the moment once you close the vocal folds, the air pressure will be built up behind this, and when the pressure rises to certain level, then the vocal folds cannot bear that pressure and it starts opening. And when it starts opening, then the air will be released suddenly, right, and with that a narrow pulse of, that means the glottal volume velocity will be increased, and when it opens to completely, then the lot of air will be coming out of that, right. So that way here this phase is known to be the opening phase, like from here to here, this is the opening phase, and this is a complete open phase, right. And the moment once it open, and then the air will be released, then the pressure behind or below the vocal folds will be less. Then the vocal folds, since they are the tight muscles, so they starts closing, because the pressure below the air below them will be less, so therefore they starts closing. So therefore this is the closing phase, and then afterwards, then if it closed again, then the volume velocity, glottal volume velocity will be 0, right. So therefore you can able to see that this is a glottal pulse, kind of a shape of glottal pulse, where here the volume velocity will be 0, or there is no air that will be released, and here suddenly the air will be starts emitting, and here the maximum air that can be released out, and afterwards again it is constant, its closing will be done. So again the closed will be there. So there are total 4 phases. It's not to be closed phase, opening phase, and again a closing phase, or here there may be slightly some open phase may be there, that depends, right. That way you can total glottal pulse can be viewed as 4 different phases: closed phase, then opening phase, open phase, then closing phase. And here the characteristics of this one, the durations of the closed phase, closing phase, opening phase, and the slopes of this, how fast it is opened, how fast it is closed, all these are the characteristics. They impact on the sound units, they impact on the speaker specific characteristics, and they depends on the co-articulation. All these things will be reflected in the speech. So therefore analysis at this level, the suprasegmental level, will be very important to analyze the speaker specific characteristics or a sound unit characteristics and so on. So this is known to be a subsegmental analysis, and if you want to perform this, you need to perform the analysis at a rate of at a level of 3 to 5 milliseconds. 3 to 5 milliseconds. And here signal was plotted corresponds to the word mask, and here you can able to see the same thing you can able to see in the next slide. Yeah, here I just plotted the word corresponds to mask. So from this you can able to observe different types of information. You at a gross level you can able to see that we have a silence over here, and afterwards we have a sound unit nasal stop, then vowel was there, then afterwards we have some frication, then again we have some stop, unvoiced stop is present. So that way at a gross level you can able to see the sequence of sound units, and also from a time domain you can able to see that relative amplitudes, because in case of nasal stop the amplitude, it's a periodic, but the amplitude is quite low compared to the vowels, right. And in the vowel also you can see that the beginning of a vowel the amplitudes are slightly lower, and at a steady portion it has a peak amplitude, and again in the terminating portion again the amplitudes will be lowered, right. So then you can able to see a periodicity, and again the periodicity also will vary from within the sound unit also, and you can see the noisy portion that can be attributed to like a frication, and you have a burst of noise that can be attributed to some stop consonants, because the stop consonants will be they stop the exhalation of air, and sudden release of that will produce the burst, right. All these characteristics from the observed from a time domain signal, right. And suppose if you want to analyze this signal waveform with respect to source and system perspective, source means the excitation source, and system means the vocal the oral cavity or a nasal cavity. From that if you analyze, you can see that this is the nasal stop, right. Because of that we have a periodic signal, periodicity is there, but the periodicity is very small or very less, it's not that much significant because of the nasal, right. And then afterwards you can have the vocal folds vibration, you can see throughout, whether it's a nasal stop or whether it's a vowel, you can see that. And the time varying vocal tract shape is also observed, right, because you can see that when you produce where it's not like it's a dynamic in nature, at the beginning of then steady portion of then termination of you can clearly notice the change in the continuous a slow change in the vocal tract shape from beginning to the end, right. All these things can be observed, and the resonances also. In case of nasal stop, nasal resonances can be observed, and in case of the vowel, a proper resonating structure can be observed in a spectrogram, right. So all these things are attributed to, some of them are attributed to the excitation. Suppose in case of a nasal stop, this periodicity is attributed to the vocal excitation, like voiced excitation, and in case of vowel, this periodicity is attributed to excitation, right? And these the resonances are attributed to the shape of the vocal tract or vocal tract system. So that way, if you analyze the speech, right, there are certain aspects that can be attributed to the excitation part, that is the source part, and there are certain characteristics that are attributed to the system part, like the vocal tract system or the shape of the vocal tract system, or the movement of articulators or the positioning of articulators. So all these things are attributed to the system level, and the periodicity or noise characteristics, these are attributed to the excitation part or source part. So that way one can able to analyze both the time domain and frequency domain representations of a speech. You can able to see certain characteristics are attributed to the system level and certain characteristics are attributed to a source level. And you can see here, for example, consonant ka, voice, unvoiced stop consonant ka. Here from these you can able to observe that there is a silence prior to the unvoiced stop, right, and then afterward there is a burst of noise, a bursts of signal, burst of noise, and afterwards there is some resonances or there is some like aspiration, like release of burst can be observed. So all these three can be observed in the time domain signal for unvoiced stop ka. Suppose for example, if it is not ka, if it is a pa, for example masp, where you don't see this aspiration and all, because but you can see the silence and a burst, because in case of pa, where the stop is, or you can say that the constriction is at the lips, sudden release of lips acts like produces the sound. In that case there is no resonator cavity is there, so therefore only the burst of noise can be observed. Whereas ka, where the constriction is at velum, so when you release that velum constriction, you can have a oral cavity, the remaining oral cavity that is after the velum, that acts as a resonator. So with that some resonances can be observed in case of ka. Whereas in case of pa, there is no such resonator after the excitation, so therefore you don't perceive the resonances in case of pa, right. So all these types of information that is present in a speech, so that you need to properly extract and you have to make use of it for performing various speech tasks. And here also I have mentioned that in case of where you can see the variations of resonances at initial, middle and end portions, and similarly the co-articulation also can see, because you can see this is embedded before the nasal stop, and after that there is a frication is there. So because of that the characteristics of will change accordingly, because there is a nasal stop, then afterwards is there. So therefore this impact of nasalization is also present to some extent here, and here the frication has to be formed here at the end of the vowel. So this impact is also present in a vowel a. So that way when you analyze the signal, the speech signal, so we can able to analyze the speech signal at a gross level, at a finer level, at a source level and a system level, where you can able to infer different types of information. Yeah, then we will move on to the next the part of the speech course. It's a processing and analysis of speech. So far we discussed about the introductory to speech processing and mainly the acoustic phonetics. It means that the acoustic properties of various sound units in terms of different classes of sound units we have analyzed. For every class we try to analyze in the time domain how these acoustic properties or acoustic characteristics are manifested and how these are manifested in a spectrum or in a frequency domain. So we analyzed all of them at different classes of sound units, and now after knowing the basic properties of acoustic phonetics or acoustic characteristics of different groups of sound units, right, and now we move on to the like from a machine perspective, because the speech is produced by human, they are the acoustic variations, pressure variations, and how those acoustic pressure variations are captured, right, and how it is represented in the form of a speech, and then how it is processed, right, and later how it will be analyzed, because what are the various types of information that is present in a speech, how they will be captured in the form of features, different types of features, and we use those features later on for performing various speech tasks by building the appropriate models, speech models, right. So now, here under this we will divide this into a processing of a speech and then analysis of a speech. And in the processing of a speech, first thing is that, first of all, how these acoustic pressure variations that are produced by human, how they should be captured, right, and then how it has to be represented, right, properly represented, and then how it can be processed to see that what are the different types of information that is present in the speech signal window. So under this, first we will discuss about the acquisition of a speech signal, that means how do you capture the speech signal. Then afterwards, once you capture the speech signal somehow, and that signal is analog in nature, because the speech is a continuous one, and by using appropriate sensor you can able to capture the signal. Suppose for example, using a microphone you can able to capture that, but the outcome of a microphone is nothing but a continuous signal or is a voltage variation, right. So therefore you cannot process that by a machine. So therefore we need to digitize that speech signal, right. So for that, what are the various steps involved in that? Then after that, we know that the speech is produced by the vocal operators by exciting with appropriate excitation, either it may be voiced excitation or unvoiced or a combination of that. So therefore we visualize the speech production mechanism as the interaction between a source and system. So from that perspective, if you want to analyze the speech from the source system perspective, so first of all we should introduce the concept of the linear system, linear time invariant system, and its response, right, what are its characteristics. And so from that, in that context, we discuss about the concepts of convolution and correlation, right. So these two concepts are associated to the LTI system, we will see that, and these concepts are also used to analyze the signals also. Particularly, for example, in case of correlation, we can use the correlation phenomena to analyze the signals, whether the signals are correlated or not, if there is some similar information is present in the signals or not, that can be analyzed by using correlation. We will see that. And also, as I mentioned that, so once we have a speech signal, right, so like we can able to see certain information in a time domain, and there is other information. Suppose we want to analyze the frequency components, so in that case we cannot perceive that from a time domain display or time domain analysis for speech. So in that case we need to analyze the speech in the frequency domain. So for that purpose we will go through like the concept of DFT, known to be discrete Fourier transform, and by applying a discrete Fourier transform we can get the information, we can obtain the speech information in the frequency domain, and we analyze this, or we discuss these DFT relations or the concepts of DFT using graphical interpretations, because mathematically we do not have sufficient time to cover that. And also, as I mentioned, that this course is interdisciplinary. So therefore, for better understanding, we will try to discuss how the DFT is performed and what are the artifacts it will introduce in the process of process of analyzing the frequency domain or moving from time domain to frequency domain. So all that we can discuss with the appropriate graphical interpretations and all. Then we discuss about different types of representations of a system. So we have seen, like, one way to represent the speech is a time domain way of representing the speech is one way of representation of a speech, and another one is the frequency domain representation of a speech. So likewise, we can able to represent the system in a different realizations or different representations, like time domain, frequency domain, then in the Z domain, Z transform or difference equations. Likewise, we have another way of representation known to be poles and zeros of a system and all. Poles and zeros of a system. We will see that what is meant by poles and what are meant by zeros, and what is their significance or what is its importance in analyzing the system performance or system response. So these are the concepts that we discuss under the processing of speech. Then once the speech is analyze, you can able to process the speech. Once you capture the speech, then once you represent the speech, then afterwards once you can visualize the speech in time domain or frequency domain or with different system representations. Then the next part is that how do you capture the features that are related to different aspects of speech. For example, as I mentioned that there are different knowledge sources present in a speech. Like for example, a speech contains a message, a speech contains a speaker specific information, language specific information, and emotion specific information, or the health of a speaker. Likewise, there are several attributes that are present in a speech, and here in the analysis of a speech we can perform different analysis techniques with which we can able to capture certain information in the form of parameters, appropriate parameters. So those features, that means here in the analysis phase basically we analyze the speech in a different ways so that appropriate features can be extracted from the speech, and these features can be used later for performing various speech tasks by modeling the speech by using these particular features and all. So we have these this time domain analysis, frequency domain analysis, and linear predictive analysis. All these various types of analysis techniques were there. So these things will continue in the next class. So here at this point of time we'll stop here. In the next class we'll continue this. Thank you.